Hi YouTube, Tim Eckert here. In this video, we're going to find a certain term within a geometric sequence. We're going to do that by writing our explicit definition and then using that to find the term. So in this first one here, it says find the ninth term of the following geometric sequence using the explicit definition. We have 2, 4, 8, and 16. So the things we need to know for the explicit definition are the first term. We'll call that a sub 1. And that's going to be equal to 2. We also need to know the common ratio, so what you multiply each term by to get the next term. So to figure that out, we can take any term and divide by the previous term. So if we do 4 divided by 2, we get our common ratio of 2. All right. Once we get our explicit definition, we'll need to know what n is, and that's easy because we're looking for the ninth term. Let me do a better n there. So our n is going to equal 9. All right, so our explicit definition is going to be a sub n equals the first term, which is 2, times the common ratio, which is going to be 2, raised to the n minus 1 power, and that's, for n is greater than or equal to 1. Okay, so now we want to find the ninth term, so we're going to say a sub 9, which indicates our ninth term here, is going to equal 2 times 2 to the 9 minus 1 power. So it's going to equal 2 times 2 to the 8th power. All right, and we can do that out on a calculator, or we could do it in Desmos if you want. Let's pull up Desmos here. We'll go Desmos, and we've got 2 times 2 to the 9th power. And that's 1024. I don't know if you can see that well in the video, but if we do that in the calculator, we get 1024 as our solution. And there we go. We're done with the first one. Okay, so let's keep going. The second one, find the 25th term of the following geometric sequence using the explicit definition. Show all work. So a sub 1 is going to equal 100. Our common ratio, we can take any term here. Let's take 25 and divide it by the previous term. So we'll divide it by the previous term, which is 50. So our common ratio is 0.5. And n is going to be equal to 25 in this case, because we're looking for the 25th term. Okay, so our explicit definition is going to be a sub n equals first term 100 times the common ratio r 0.5 raised to the n minus 1 power, and that's for n is greater than or equal to 1. All right, so our 25th term is going to be 100 times 0.5 to the 25 minus 1 power. So that's going to equal 100 times 0.5 to the 24th power, which we could do on Desmos. So 100 times 0.5 to the 24th power, and we get let's see, 5 zeros and 596. So a very small number, 0.1, 2, 3, 4, 5, and let's check. I get 596. All All right, and so that's the value of our 25th term. Just check that, make sure I got that right. Let's see, 1, 2, 3, 4, 5. 596. Okay. All right, there we go. Okay, so that's our answer for the second one. Let's take a look at the third one. It says find the 11th term of the following geometric sequence using the explicit definition. So we got 3, 18, 54. So our first term is 3. Our common ratio R. Let's take 54. We'll divide by the previous term. So divide by 18. And I note this one is not a good problem because I'm getting 3 here, but if I divide 18 by 3, I get 6. So this is not a geometric sequence. So that was a trickster. So we're going to eliminate that problem. We'll cancel that one out. All right, problem 4. Find the 18th term of the following geometric sequence using the explicit definition. Show all work. All right. So we're going to go for our first term, which is going to be 1,000. We'll look for a common ratio. So let's take 62.5 and divide by the term before it. So divide by 250. If I do that, I'm just going to use my TI-84 here to do that. We get 0.25 as our common ratio. And then we want to find the 18th term, so n is going to equal 18. Okay, so if we write our explicit definition, it's going to be a sub n equals 1,000 times 0.25 to the n minus 1 power, and that's for n is greater than or equal to 1. All right, so to find the 18th term, we'll say a sub 18 equals 1,000 times 0.25 to the 18 minus 1 power. So that's going to be 1,000 times 0.25 to the 17th power. 0.25 to the 17th power. All right, so let's do that. So we got 1,000 times 0.25 to the 17th power. We got 5.82 rounded to 5.821 times 10 to the 8th, times 10 to the negative 8th. So 5.821 times 10 to the negative 8th power, that's in scientific notation there. That means we take the decimal place and move it 8 places to the left and fill in with zeros if we didn't write it in scientific notation. Okay, there we go. There's our solution for our last problem. Hopefully this video was helpful. If it was, please like and subscribe. And feel free to share the video with like-minded individuals. You can easily just share by copying the link on YouTube and sending via email or so on. Anyways, thanks. Hope to see you in the next one. Bye.